it seems very natural to our way of thinking in physics that the meeting point of general relativity in quantum mechanics is on quantum field theory and it's in quantum electrodynamics, and that therefore to provide a unification of gravity with quantum mechanics, you need to look at how quantum electrodynamics can be applied in a general sense to the universe. And some of the more recent work on quantum gravity that's been emerging now in the last 10 years or so from people like Felix Finster in Germany, and slightly more than 10 years ago, I think he started working on causal fermion systems and so on, and bringing back these notions of like a Dirac and things like this. And I would have gone further and brought back the whole conjecture of Paul Dirac, and maybe we could frame that as something like Dirac's greatest blunder, that he gave up on this idea of the whole conjecture, these holes in the background, through which might be tunneling W plus particles to then be reuptaken by the background in exchange for a photon. And it's these W pluses that we really are calling positrons. There's actually no antimatter in the universe, which I mean is a real stretch for a lot of people, and an idea that I'm sure a lot of people would not like to give up on in physics. And I don't like these idea of creation and annihilation operators and things like that. That's not how I see the universe. I don't see energy and matter being created and destroyed. I don't see any creation and destruction of matter and energy in the very early universe either. And I think this is one of the reasons why if I were to study a physics degree, I'd flounder and be unable to really accept what I'm being taught. I don't think. I don't think there's the evidence in my mind stacks up to quite the existence of antimatter as such. I think it's just the matter that we have at the moment behaving in rather a mysterious way, rather a way that's rather subtle and obscure for us. However, I don't think what we're seeing is a coterie of novel particles which stand as the antimatter counterparts to the particle of the Standard Model. I don't see that at all. But yeah, to go back to quantum electrodynamics and this meeting point between our theories of special relativity and quantum mechanics, then I see that as like you could extend that a little bit further, couldn't you? You could say like quantum electrodynamics is a theory of the interactions between matter and light. You could say, well, okay, let's have many bodies within the system. Let's have more electrons, more photons. Let's say these electrons are bound around particles of matter, and I think you'll see where I'm going with this, that the electron, the quantum, the granular structure of gravitational fields is given by tunneling electrons, tunneling electrically negative particles, tunneling particles interacting readily with the electromagnetic field. So you can see via those means, I think, how including flows of many photons around objects, around, or being deflected by electrons in the gravitational field. You can see very much how these effects of general relativity, I think, so far as it pertains to light, might arise out of such considerations. And yeah, I see that being the ultimate direction in which theoretical physics will go, and that it will acknowledge at some point that there is this gravito-electroweak unification between the force of gravity and the electroweak force, that gravity involves W pluses and W minus particles being exchanged, and things such as this between atomic nuclei and tunneling background electrons. And I'm sorry, you can almost have a drinking game, couldn't you, in these videos, where for each time I use the term electron, because it does just come up so much, and it comes up so often, and it's such a quantum mechanical object in terms of the way it behaves, in terms of these tunneling behaviors, and in terms of this changing in position every time it collapses, since you can imagine the photon interacting with the electron swallowing the photon and then collapsing into something like a singularity, wherein this photon, which I'm imagining as a point particle, is making a measurement of the photon, of the electron, and via the uncertainty principle, the accuracy of that measurement eventually starts to approach this limit given by h bar over 2, and therefore it compensates for that by increasing its momentum. So its momentum increases to superluminal velocities and to speeds beyond the speed of light, i.e., and then it tunnels to a different location instantaneously or instantaneously. So it might just be traveling. It might be traveling at c squares. It might be traveling at some speed greater than the speed of light that we don't know about. It might be traveling infinitely fast. We don't know, I don't think, quite yet. We also, furthermore, and more importantly, I think, do not possess the means of delineating between an object that's moving infinitely fast and one that's moving merely at the speed of light, since we have no coherent means of deriving measurements from such a system, or deriving measurements of such behavior, or deriving quantification of behaviors such as that. So yeah, that's what I would like to contribute to quantum gravity. I'd very much sponsor this idea, which might have a corollary in causal fermion systems. This theory of Felix Finster's. It in this idea that the background is deeply granular, formed of a sea of electrically negative particles, i.e. electrons, tunneling all around the universe, interacting constantly with photons. But instead of it being a causal fermion system, really what I like to refer to it as is a causal fermion boson system. So the entirety of the background is what I would like to call an energy economy. And you have actors within the economy, which are fermions, exchanging particles of energy. So these particles of matter, fermions, exchange particles of energy, i.e. bosons, with one another. And that is the central fundamental causal mechanism of reality. So we have electrons exchanging photons with one another. We have electrons exchanging W particles with atomic nuclei. We have all sorts of things going on. Neutrinos exchanging Z particles with the background, and other things of that nature, and all sorts of things like that's going on to explain flavor oscillations of neutrinos. So I hope my idea eventually takes off and gets the recognition that I think it deserves as the correct theory of quantum gravity, and not, as that, yeah. So thank you for watching. Just a little update on quantum gravity I thought I'd submit now, and thank you for watching. Love you lots. Bye.